Dunk. Ooh, hey.
I'm in the good one. Yeah, I think I saw Marco.
Hey
Hello,
there.
how are you doing, Antonio?
Hi.
Hey.
We'll give people a few minutes to navigate through everything. Did you paste this in the channel yet?
I was just doing that.
Okay, I will interrupt.
Hello.
Hello, Abhishek.
Hi.
So Vivian typing in the batch working group, and then I put the link, and then she stopped typing. So I imagine she was looking for the link.
Um,
Hello, Philip and Philip. Your innie and outie is both here. Oh, he can't hear me yet. Hey, Alan. Nice to see you.
Hello. How are you?
Good. Are you in an office phone booth or a home phone booth?
I'm coming to you live from inside a 1970s football.
That's good.
Yeah,
It's
it's
sort of
got
swelled up a bit. It's like a little bit larger than it used to be. That's what
yeah.
happens to old leather. It sort of deteriorates, and then yeah, you can yeah. That's good.
I see a few folks on the other Zoom meeting. So I've
Really?
joined two Zoom meetings at this point, and there is Skylar and Claire on
Do you
other
I'm
want
Zoom.
sending
to?
them the new. Hold on.
Yeah.
Okay.
They're on
Thanks.
an
Okay.
old invite thing. That was my fault.
That's all right.
Okay.
I tried my hardest to
I
scour for the old.
I actually did send them links and they didn't notice. Okay.
Yeah. Still a few bumps getting to this new platform.
Yeah, you know.
Hello, Philip.
Hi, Alex. Hi,
How's it
everyone.
going? There were two of you just before. I was concerned that you'd had some sort of split brain problem.
Yeah, when one Zoom crashes, a different one joins the meeting, so I had a few of those ongoing demons.
Got it, got it. Hey, Vivian, I saw that you were, I think, about to ask what the Zoom link was, just as I dropped it in.
Yes,
Glad to
I
get you in
was.
time.
Yeah.
My pleasure.
Right before I hit send.
Yeah. And nice to see you, Antonio. Thank you for joining again, getting the getting this meeting rolling properly this time, it seems. Who else we got? Sohan, or I don't think they can hear us yet. Skylar, James, nice to see you all. Give another minute or two.
Yeah, I figure even if Yuki doesn't show up, is there anyone who's an expert on or knows anything about the MPI operator? Because that's the part I want to see is getting the DRA net plus MPI operator functioning together.
Not me.
We already have. Can you hear me? Because my
Yeah.
okay. We already have an example on the documentation for DRANet with the MPI operator.
Oh, really? Can we run
Yes.
through that, please?
Oh,
Yeah.
I mean, you are putting me in
Okay.
the spotlight. I did
Yeah,
it like
sorry.
6 months ago.
Well, we'll maybe I'll just go through a bit of house
How-
cleaning first, and maybe Yuki will join. Yeah, let us just go through a few things really briefly. Yes, we have changed to a new platform that will hopefully at some point be easier. Mainly it's the same thing, except that automatic meeting notes will get generated and YouTube things will get automatically generated, and that will be lovely for me. Because until now I have been handcrafting the notes with Claude or whatever, but I have to like go into Zoom, the back end of Zoom, and pull the links out and do things. Hopefully this will be easier for that. There are often times where people miss the meetings, want to check it out because there's been some useful discussion, and it's sort of locked away behind the Zoom management thing. So we've moved to this new system. It has not been gentle or easy, as the last couple of weeks have shown, but it seems like we might get on there this time. I think the only other thing to mention is the other discussion that Marlo is leading around the white paper. Marlo, you want to give a plug for that?
Yeah, sure. We're actually pretty close to completion, believe it or not. So we have the scheduling paper for basically scheduling AI in Kubernetes, and Sabrina went in and took the content that from a couple of years ago and cleaned it up and gave us a better format. And so we've been targeting various pieces to do updates and make sure it's accurate. And so everyone has areas signed. So you're welcome to go ahead and add material or not to that paper. Let me find the link for it. Hold on one second. There we go. It's one called New Draft. Over here. And we meet every week right now. When's our next meeting? Hold on, I'll answer you or answer me. Next meeting is tomorrow at 10:30 Central, 8:30 Pacific.
Yeah. And I don't know whether we can get a link to the meeting invite or what.
It's the same place you just had to go in order to get this one. We're also in that elephant.
Oh,
Yeah.
using the same Zoom?
Yeah.
Oh, okay. Cool. Then
Well, I think it's a separate one. Hold on, I'll tell you what it is.
yeah, I think it might be somewhat different. We'll see.
I think I might change every time. You still have to go to their calendar to find it.
Really?
Yeah, here's their calendar. You can just
Cool.
find the today item.
I thought we had checked, and I thought it was all a static link for each
No,
invite.
you're right.
Yeah.
There's your link address. There we go.
Cool. I think that's it for updates or PSAs or news announcement things. Is there anything on anybody's mind, maybe related to KubeCon Europe or things like that? Anybody speaking that this group should know about? I think, Marlo, you've got a couple of meetings, yeah? A couple of speeches.
No, I have 3. There's the Maintainer Summit where we're talking about where native resources are going in the future. So there's a whole panel of us. And then we have the Slurm Bridge. Kevin has one too. We have the Slurm Bridge working with native resources DRA, a CPU plugin, a demo, and slides on that. And then there's a Workloads Foundation talk now on Wednesday, which I've been pulled into, and we'll basically cover what we do here, but maybe there will be other content. Kevin, take it over.
Yeah, I have the working group batch talk on, again, second to last session of the conference. So I think it's at Thursday at 4 p.m., whatever that time zone is. We'll probably focus a little bit on bringing up the workload aware scheduling efforts that are going on in Kubernetes for adding gang scheduling and topology aware scheduling. Kind of trying to highlight the collaborative effort the Q community is doing working with those folks. So probably what we'll do. I haven't made the slides yet, but also we're going to rename the Q booth at the project showcase to also highlight workload aware scheduling. I think there was a lot of confusion and a lot of interest in how Q is going to adapt some of the newer Kubernetes features that are still alpha, but we kind of wanted to have something together to answer those kind of questions. So if anyone's interested, that will be there too.
You should name it like workload aware scheduling management so that it like conflicts with WASM stuff. And like people think that it's all going to be WASM, and then you get WASM people showing up, and it's like super confusing.
I haven't heard that term in a while, WASM. Yeah, I forgot about that one. I never even thought about it when I saw the acronym is WAS. So yeah, makes sense, but.
Super cool. Anyone else either going to KubeCon Europe or speaking? Yeah, Antonio, you're headed there?
Yeah, but I'm mostly on networking thing. And well, I imagine that the DRNS is going to be in the spotlight because we have a lot of people that start to use it. And well, I don't know if Marlo invited me, so I don't know. I don't want to hijack this. I can explain later.
No, I think we want you to hijack this. That's maybe a good segue into the topic for today, DRA and MPI operator and things like that. So, yeah, Marlo, did you want to sort of set the context?
Before we go there, James is here. James has started an effort on benchmarking.
Oh, cool.
James, do you want to jump in at all?
Hi, sure. So actually, I was looking at the project of Batch WZ and came through the benchmarking. Then I tried doing some docs thing, and now I'm looking for the teams or bunch of people to work together on it. So I'll just drop the link here in the chat.
Cool. That's lovely. And that's for everyone who doesn't know, like we have various streams of work coming out of this group, and there's the AI batch working group thing, the AI batch white paper thing that Marla was talking about, and then we hope to do benchmarking around batch scheduling and various approaches. So another piece of work that we hope to do.
And guys, please feel free to edit these docs. I might have not written it correctly, or some pieces might be missing. So please feel free to check it out. Thank you.
Cool. Thank you very much for taking that on. Really appreciate it. All right. With that, I think we'll circle back to Antonio and Marlo. Do you want to give any context introducing the topic?
The beginning context is there's still how does MPI work, especially with PMI behind it, with SRIV or with DRANet. And so I was curious how we could get that working. So I'm gonna go look at the link that was sent earlier, and I'm gonna let Antonio take it away.
Should I?
Yeah.
Okay, so just a bit of context. On me, I work at Google and I work in Kubernetes. I'm one of the TAs for Signal, and we never were pretty involved on these AI MPI workloads until I think that you may know Vanessa from Livermore Lab, that she's working on Flux operator or something like that. Well, she reached out to Signal because she was doing some benchmarking. And that was my first contact, and I think the first contact with Signal with MPI and all this RDMA and all this stuff. And after that, investigating on her issue and checking our internal stuff and the new issues coming to Kubernetes, we found that we needed to do something in Kubernetes to handle these new workloads because they were different from the networking point of view, right? And we also had traditionally a lot of push from the telco people to have a better integration with networking on Kubernetes. So that's when I started to talk with Tim Hawking, John Belamarin, Kevin, and Patrick from NVIDIA that they were doing DRA, that the dynamic resource allocation. Because I found that the common denominator for all these things, we can advance, but at least all these particular network workloads in telco and also in AIML had a common denominator that was the network interface. So just allowing the primitive of moving network interfaces between pods declaratively, we can solve we can start to solve the problem. So that's what DRNet does. Basically, it explores the host and it publishes the network interface resources and allow people to claim the resource. So then I want to share one doc that's a one-pager with the problem. Then once we have the primitives and the basic functionality, we need to solve the problem. The inter-node match and the intra-node match. So for internode, basically what the main demand for people was to improve the bin packing. So they wanted to, they have these expensive machines and they want to have workloads that can compartmentalize the node. So they have 8 GPUs and 8 NICs. They want to use 4 and 4 and the other 4 and 4. I'm not an expert on those details, but they wanted to split the node. And we found that you need to match PCI route between the NICs and the GPU. That's how the hardware, at least in Google, is how they build the hardware. So they have the layout with the PCIs are attached to this. The GPUs and the NICs are attached to the same PCI, and if they cross through the PCI buses, they have a big penalty. So that was the discussion in Absinthe, and we agree on implementing a model of driver composition for the array. So the NVIDIA guys have the GPU DRA driver. We have the ArrayNet, that is a network agnostic, no vendor driver, and we agree on an attribute that allows the user to say, I want to choose GPUs and NICs, and they need to match in the same PCI. So that is working. That was released in the 134, I think, GA of the array, and that solved a particular problem. That's the internal topology. But then the problem is bigger because when you use these NIC workloads, they are distributed. So then it's not that you need to match the same NIC and the same GPU in the same PCI. You need to match also the layout of the data center. Typically, at least in Google, we created a convention. So NIC 1 goes to NIC 1 of the other host and NIC 1 of the other host. So all the NIC 1s are in what the NVIDIA terminology, I think that is called, is rail oriented. So you get a rail, it means that the physical layout of the data center has the optimal performance and latency. This is the part that I think that Kevin touched on that, is the people is working on Kubernetes in a workload gang scheduling, and this is the dot that I shared is the requirements I put to this group is we want for the networking point of view to do match scheduling at the device level. I think that Marlo is here, can correct me. Slurm and the common existing network topology is more at the host level. So you have a layout of the data center, you have the hosts that are connected to switches, and they calculate the graph between that. And what I'm proposing, and there is some people from NVIDIA also working on that, is to do this at the device level. So we can create more complex topology, and in environments like cloud, that we can have a fabric that is more elastic. We can also implement self-healing and more features that are very important for this kind of workload. And with this, I think that it's an overview of the work we are doing and how it's going. I don't know if you have any more particular questions on the one thing is because Marlo mentioned MPI. The other thing is that in the ARINet, we try to be as much as agnostic of the application as possible to make it more portable. So what we found with all these nickel, when all these distributed MPI flows usually use nickel or MPI, and they have a discovery mechanism to create the graph and provide the communication. So we tend to not touch anything at that level. So we just plan the interfaces the way that these applications want, and are those applications like MPI or Nickel that discover the topology and do the graph and use one or other interface to communicate between them.
So I think maybe if you give an example of like you're drawing a distinction from how batch schedulers today do topology and how you're doing topology. You're talking about like doing it on a device level, but can you give an example of what you mean by that? Like what that topology looks like differently from what it looks like now?
The difference, look, I'm not expert in this area. I'm from networking, and I just jumped into this environment 3 years ago. What I see right now is all these workloads can assume that they have the entire node, right? And that is a lot of money, at least in cloud. And what I see is that people won't have the nodes, right, with all the GPUs and all these hardware resources, and they want to compartmentalize the node. So instead of using the entire node, they may use 2 pods in each node. That effectively is like they subdivide the node in 2. So that means that there are different workloads running over the same node, but then, if it's distributed, it means that you need also to subdivide the kind of the fabric and the hardware infrastructure. That's what I mean with the compartmentalization.
Abhishek, you have your hand up.
Yeah, thank you. So this is very interesting, right? Actually, you answered a part of my question, Antonio. Like, so you said, people prefer using whole nodes, right, to get around this problem. So, I don't know, like one of the use cases of this work would be when a cluster is fragmented and you need some sort of topology, then this DRAnet feature would help you to place your pods on the same PCI route. Is that a correct assumption?
Yeah, it gives you the capability that if you want to create workflows based on devices, right? Instead of aggregating in nodes, you can say, okay, I have 8 nodes, and I want I want to create 2 workloads that are each node has 8 GPUs and 8 NIC, and I want to create like 2 cluster of 4 GPUs NICs, that effectively give you the capability to subdivide these 8 nodes like they were 16 nodes, with half the capacity. I'm very bad friend. What I'm trying to say is that it's kind of a virtualization of the data center, right? You have 8 nodes and you create a pod that create a workload that requires 4 GPUs in each node. So it means that you can have 2 workloads in these 8 nodes, consuming the half of the node. So DRA-net and DRA and GPU DRA driver, what they do is they expose these resources. So it allows to the user to be able to implement this. Well,
Okay.
let's say it's just exposing APIs to the user. It doesn't give you the the full orchestration capability. It gives you this capability.
Yeah, thank you. So two more questions. Sorry, this is very interesting. So the second question is like, how deep is the alignment? Like, do you stop at NICs and GPUs, or you do go down the CPU NUMA node level also?
That's a good question. Yesterday, no, it was 2 days ago in the chat in Kubernetes, somebody is asking for this question, and we were brainstorming internally for 2 months about how do we do this, right? And there is I'm not an expert on this area, but the hardware people from Intel and I don't know the other company, well, there is some disagreement with NUMA. I think that different platforms expose NUMA different. So we wanted to agree. What we just need is to agree on the parameters. So we all discover the same thing and we're matching the same material. So once we have the same parameter, each driver will publish one or other thing and will match. With CPU, we have Marlo can contact you. We have Praveen that is working on that, and he's also doing a DRA CPU driver, and he did also a demo of using DRA-net with CPU aligned. I can look for that. I think that he had a doc or something like that. So basically, we are building the pieces and we are building on use cases. So that's why we didn't went through with the NUMA and all the stuff. But as I told you, yesterday someone asked for that. We have an internal request and we're planning the feature how to integrate it. So most probably in this year we'll release something around that.
Okay, great. So last question for now. So while initial discovery and placement is good, what is your take on some sort of monitoring, right? Because a GPU may fall off the bus, right? And it might affect the trading or multi-node inference workload. So does your DRA net also do monitoring with
That's
this topology discovery?
so you are a step ahead. So that yesterday had this conversation with the PM from Google about that, right? How do we expose it? So and the challenge we have here is what you say is how do we? I don't want to expose raw metrics in the sense, oh, I can expose bits per second to whatever thing, because that I don't feel that's something people can act on that. So the end goal is to expose something that an automated system can react to that, right? Because what is important is self-healing or this kind of thing, right? We in this area we are not talking about we are going to have more the traditional web thing, right? We have more things we scale out, or we want to detect something is wrong, and if it's the hardware, just spawn a new node or I don't know, change the rail or whatever thing. And for that, what we are finding is that it's complicated because you need to go up and down on the stack. We are trying to talk with the nickel team to correlate metrics from there. There is also another project at Google that is called Straggler that offers this capability. So I would love to do that, but I think that we need to explore this further. Because if we just expose bandwidth, throughput, or not even latency, we can do is we don't feel that people can act on that, because what we know is, oh, it's my training job degrading. That's the thing that I want to get. But honestly, I think that I'm open. You people know more than me. If you have ideas, please let me know.
Thank you. Thank you so much.
Kevin.
Yeah, so I was just kind of curious on what I don't quite get with like DRA. Usually there's always a dependency on a vendor for the driver. In this case, you have a driver, but I am a little unclear how this interacts with like the NVIDIA DRA driver, or if the AMD DRA driver ever comes out, like how these like would work together. It's like it's a little unclear. Like if I want to deploy this, like what for GPUs, I imagine I still probably need the NVIDIA DRA driver too.
Yeah, that's okay. So what you are in this discussion, and the goal in the array device, somebody in the device management working group is we are going to build applications by composites, right? So we need to. That's why we have attributes and we have these matching. Matching attribute. I don't remember constraints, right? To match between things. So the goal is that everybody exposes their devices in a way that they can compose the workload with other devices. In the network side, we have a good thing that is the kernel has a Linux network device abstraction. So it doesn't matter that you have Melanos, that you have Intel. Well, it does matter, right? But at the end, you have a common abstraction. You don't have a common abstraction for GPUs. So, well, I'm talking out of my expertise, but I think that you don't have abstractions for this, more specialized hardware. But for network interfaces, independently how the vendor configures or initialize that, right? At the end, it's going to show up as a network interface. And that's the thing that you can move. You have common APIs for doing that. And that's where we are basing the point of DRANet, right? You can move all the network requirements without, requiring the hardware, because that means that you are able to compose workloads from GPUs from AMD, GPUs from NVIDIA, GPUs from Intel, and blah, blah, blah. That's our aspiration. Then if we tomorrow find that, Melanos, NIC, MLS, whatever thing doesn't work, we need to figure out how to solve it. But so far it's working great. And we have Intel and Melanos NICs in Google. That's a proof of this.
So like to overly simplify it, it's more like the networking devices are kind of a schedulable resource, and then the GPU is kind of a separate request. So you would still need like if you wanted the GPU access, you still would request the GPUs to the DRA driver for NVIDIA, but the networking is a separate resource claim. I guess you can combine them.
Yes, exactly. Okay, sorry. I went to the low level and you were asking for the UX. Okay, apologies. Okay, you can see an example with the NVIDIA. I put a lot of emphasis on the documentation because this is the kind of thing that is easier to see than to go. If you go to that document and you scroll to create to the workload, you can see examples of the resource claim and resource claim template. And you can see the -GPU-NIC aligned resource claim template, and I think that will clarify what you are asking for. It's almost at the bottom of the documentation.
Thank you. That was helpful.
Yeah, I mean, I guess where you're going, Kevin, is like, how would Q use this, right?
Or
I think generally part of me was just wondering, like with DRA, I always think of like, there's an API, then there's a device driver. So then like when I was trying to understand is like, if I wanted to support this, do I need, like, it wasn't as clear to me, the interaction with the NVIDIA or with the device drivers, but I think I'm getting it now, but please go ahead, Mara.
I think it's separate, right? You still have to do the dynamic resource and get the stuff dropped in the pods appropriately.
Yeah, I mean, how do you mean separate? I mean, I was assuming that where this conversation goes is like, how do the various batch schedulers and workload managers that are represented by various people here use this and take advantage of this when doing scheduling of resources?
Okay, so sorry, I didn't mean to.
I was just wondering whether that. So Marlo, you're saying they're separate, but yes, they're separate, but aren't they to work together? Isn't that your?
I mean, they all have to be dropped in the pod and then work together. So the workload still have to understand about it. I have a question, which is if you've done any, I saw on that site you dropped in that there's a benchmark. Have you done any benchmarking of just plain MPI linpack type stuff versus through MPI operator yet?
Which benchmarking in which sense? So right now it's as you say, right? Is you have a phase that is you just need to schedule and allocate resources, and then you need to run the application that is going to consume these resources, and the application is in the container, right? Well, it depends what the schedule is. We did benchmark to demonstrate the intra node alignment. So
Yeah, I
that's
saw that.
Yeah.
Yeah.
We have Praveen had some benchmark with CPUs. And now we are having internal development and they are doing benchmark with more complex things, but they are not public. And I hope we can start publishing things. But yeah, this is it's not going as fast as I wanted. This environment is much more complicated to work the one that I used to work. But so far, as I said, is working fine. The next thing is the topology aware scheduling and the rest, and and test with more dynamic fabric thing, and that part is more convoluted.
I guess to answer
Barlow.
or sorry, go on.
Yeah, one question is I answered, but is there any benchmark people is interested in knowing more about?
I think we're going to have to find them because we need to understand what the performance is on this versus bare metal, i.e. what we're leaving on the table if we're missing something in the stack we need. Kevin, do you have comments on this?
Sorry, I was going to bring up I was answering Alex's question about, at least for me, like one of the things we're working on in Q is slowly trying to make sure that Q is aware of resource claim templates on workloads. And the way I would see the integration here would be that users on a workload request like a resource claim that also requests the NIC and the GPU. And the idea would be that the quota management would go at that layer. Seeing this use case does make me realize that we need to make sure that Q can actually evaluate those cell expressions, which is the one thing that we don't necessarily handle right now for our DRA integration, just because I guess we didn't get to that and we weren't sure how pressing that was, but it sounds like it is. So like that's sort of the challenge, I guess, with DRA is the scheduling stuff it's a little bit more challenging than the simple count based. So I'll have to make sure to bump that up in priority.
I want to reply to Marlon. We already run DRAnet in bare metal. We have I think that they published recently new A4 whatever Max machines, and those are bare metal.
Is that useful to you, Marlon?
Yeah, I'm thinking about the DRA integration with scheduling piece because we're doing it for Bridge, for Slinky Slurm Bridge. But but a lot of the stuff we're doing for CPU specific is not dealing with SCL or CEL, sorry.
So
I'm wondering if we absolutely need that, I guess is where I'm going.
Sort of want to go back to I think Kevin's question, what do I need to do for vendor compatibility? And the example you gave, Antonio, GKA with NVIDIA DRA and DRAnet, you install the NVIDIA DRA drivers. So if I'm running a big batch workload, like I've got a large amount of resources, to make this work, I need to spin up all my Kubernetes stuff and also run this Helm chart in the cluster so that it has the NVIDIA drivers. And I would know that I'm running NVIDIA gear, and so I know that I'm going to run that Helm chart, right? That's like my first step when I'm setting all this up. Yeah, and then what that allows me to do is sort of just request a device class as opposed to having to specify the NICs that I want the pods to work on. Is that the simplification that I get out of this?
Let me go with the risk of the obvious. Let me start. So you install a driver, right? In this case, you want a driver that handles GPUs. You want a driver that handles NICs. Okay, so you take the DRA GPU driver and it installs a daemon set. Okay, it goes to the node, it discovers the GPUs, and it publishes a resources line. You have an object that is resources line. Then you deploy the DRAnet. I don't use Helm. It's a simple install. It's a daemon set. It goes, the DRAnet goes to the nodes and discovers the NICs that are special, that know that is special, and create their own resources line. So at that moment in the cluster, you have a lot of resources line objects that know, each owned by each driver. That's the system, right? Mm-hmm. Now you are the user, and you want, then it's when the user start to play with these claims and claim templates, right? That's when is the user intent is there. Oh, I want my workflows to have GPUs and NICs, and they align it by the same PCI. So you can build your thing with the cell expressions and all this stuff with the claim templates. And you associate the claim template to a workload, to deployment or whatever thing. So the system is going to see, okay, this pod requests all this bunch of resources, and it's going to be a generator of pods, right? A deployment at the end is going to generate different pods. And the scheduler understands all these resource slices, all these expressions, and everything is going to make the right choice. It's going to say, oh, this GPU in node A has a NIC with PCI and the other thing. And then once the scheduler agrees on something, they start scheduling the node. So at that point, I don't know if I'm going too far or you want to stop.
No. I think that's good. I think I'm understanding it correctly. Like I think to the end user of a batch system, like many of our systems right now, we use like taints and tolerations to say, hey, I want these nodes, not these nodes. And
yeah, that's the part that you remove, and you have now a dynamic way of scheduling. Before, right, you have manual labeling, and you have to be handpicking, and the admin need to be sure, and you don't have automatic discovery and everything. That's totally what changes.
Yeah,
the driver, the driver does the label discovery and the resource discovery. It's like a device plugin with steroid. So instead of have, and that's the key part and why you need to use cell or CEL, because you have opaque attributes. So each driver is going to say, oh, I have this attribute, and you can match on this attribute. And the scheduler is able to match on this attribute. So you remove the manual process of node labeling and device plugins with something more sophisticated, more complicated, but more sophisticated, that allows you to start to create these combinations of different resources.
Yeah,
via the API.
It's maybe sophisticated under the hood, but the goal, I think, is to get people away from having to manually label things in the system and having the users of the batch system understand the infrastructure to be able to choose nodes. They just ask for a device class that is, hey, I want NVIDIA nodes with fancy NICs, and the DRAnet thing will figure it out for you. That's the point. It's you said more sophisticated, but actually it should be simpler for the end batch user.
Look, maybe the word is the wrong word. I translated from Spanish or something. I just wanted to me, is more complicated to understand. So there is a steep barrier. I mean, I've been working with a working group, and you do the demos and everything, and there has a lot of new concepts, a lot of understand how it works. It takes some time, but once you fully understand, you are what you are saying. I think that you already got the graph is okay. The system is going to provide you the resources, and you can look for these matches. So you no longer need to be in the hook of configuring the infra. The infra theoretically will be, exposing their attributes automatically.
Yeah. No. Thank you. Just making sure that I had it understood. Marley, you had, I feel like, specific questions around like MPI and how that was going to work together. Do you have formulated questions or? Yeah.
I think I need to go play with this thing because some of this is like an ideal stack, of course, for me is using our scheduler, but people will want to use others. And then running this maybe with Kubeflow and seeing just what happens performance-wise versus running the same workload with just bare metal.
The key thing with the MPI operator, is that they have a template for workers, so you just embed the resource template there. So basically, it just plan through the configuration.
Okay.
I mean, Molly, you made it. Oh, Kevin.
Oh, you can ask your
there's
question.
more docs.
I guess if there's no other questions, what I was curious on is how is this going to work with the Kubernetes like workload aware scheduling? I mean, in particular, the topology aware scheduling that some of the other Google folks are proposing, because I'm having a hard time keeping together all these ways of getting these resources. Because I know I know this is kind of at the NIC level, but it feels like there's a strong overlap on the topology aware scheduling aspect with this work.
Yeah, that's actually, I shared the one pager that I shared, in what was the last QCon was Atlanta. In Atlanta, they created a summit, right? And there is Nadia from NVIDIA and that's where we went there and say, okay, we want to do topology aware scheduling to match on device level, not on the host level. I didn't follow up. I know Wojtek Tysinski and Marco, some teammates are working on that, and John Belamarik, and they already sent another summit for the QCon in Amsterdam. So I'm going to touch base again there and follow up with that. The requirement for networking is, as I say, I just want to be able to define. I want these NICs to be in the same rail. How is what I tell guys, you are doing the LPI. I just want to be able to do it. Unfortunately, I'm not having time to work on the implementation. And ideally, that's my requirement for them. Is I want to define on the API level. I have already the intranode. I want to be able to define internode. And internode means I want all these NICs to be in the same rail, whatever rail it means. Okay, rail as a connection or between nodes or whatever thing.
Yeah, I mean that makes sense. Yeah, I think we all want the same thing. Yeah, it makes sense. Thank you. And I'll definitely be at that workshop. I already RSVP'd for it. So.
Marla, you sound like you had said something just as Kevin was starting to speak. What did we cut you off or?
I already forgot what it was. I'm still looking through this doc.
Interestingly, I see that there's native resources in DRA, a meeting in the next.
Yeah, directly after this. Yeah, there's one every week right now. So the summary of the CPU. Let me find the meeting for you. I'll throw the link in here.
Yeah, I think I got it.
Yeah, but other people maybe don't.
No. I was putting it in here.
It looks right. Yeah, that's right.
Yeah. So, what's the gist of that one?
The gist is we started off with CPU, and now we have individual mode and grouped mode, where grouped mode is, here, I'll turn on video. I didn't realize that was off. Where grouped mode is basically not doing individual core assignment, and individual allows for individual core assignment. So if you're more controlling like Slurm controller, you can do that. And now people are talking about adding memory. So there's a whole discussion, especially huge pages, right? We want huge pages in there at the DRA level. And then we'll keep going from there. Sasha keeps talking about network attached storage. So that's in there as well. So it's become a weekly one because we have, I don't know, I think people want to take the CPU driver and add memory to it. And I'm still on the fence because I think making a separate memory one may be smarter. But I don't know for sure what the better path is.
Well, that's certainly something that, like, as things progress, let us know what is happening. Seems like there are interested parties here.
Yeah, I mean, feel free to show up and start. It's every week or every 2 weeks, sorry. Yeah. Every 2 weeks on Tuesdays at the top of this hour. Or the bottom if you're in India.
It was all very interesting. Any last thoughts on any of this DRAnet stuff?
I'm curious if anyone has like started using DRA as a user.
I know we have at G-Research, not using DRAnet, but yeah, we do things, but I'm not sure what and how. I could look some things up real quick if you're interested, but
I mean, no, it's okay. I mean, if I'm just kind of trying to gauge like adoption of DRA from end users at the moment, because like I know that at least from my visibility, things are still kind of slowing. Like people are slow to adopt. I know a lot of our users are, well, I haven't talked much to users, but there's a lot of interest in the extended resources to kind of mitigate migration paths to using resource claims. But I think there's going to be a lot of downsides for that, especially for what Antonio is proposing, because I doubt we'll support that for, extended resources. It doesn't really make sense in that case. So, but sorry, go on.
My perspective on this is a long discussion. It's like Python 2, Python 3, IPv4, IPv6. Right? If you give the same just with different flavor, people is not going to change because they have a massive amount of franchise, manifest, whatever thing. That's why we are pushing a lot on having the entire history. We, as I told you, we have fragments, right? You can allocate a NIC with everything, allocate a NIC with a GPU. But once you are able to provide this full thing to say, okay, these machines are very expensive, and say, okay, you can bin pack your workflows. The most questions I have is people that won't bin pack because they run training and inference and say, okay, I want to reuse as much as possible by now. And this will allow them to do that. But for doing that, we still need to flesh out more the entire experience. That's why I'm saying, okay, we need to involve the fabric elasticity onto the thing, the monitoring, the self-healing. All these things need to start to play together. Right now, it's kind of, oh, we are doing the drivers, we are the happy case board, but need to iterate on that. And we need to provide, I think that the key is the moment that we provide self-healing with an automatic controller or queue or whatever thing, that it's able to handle this thing, that's when people will start moving. if you tell them, oh, you are going to use this like a device plugin, yeah, it's okay, but
Yeah, I do feel like it's a C group C1 V2 kind of problem where people will finally like maybe start like they'll migrate when they need to, but they might not. It might take a little while. But
look, it's the bill is expensive. So I'm telling you, if you are able to give them a chance to run more things, for less money, that's a no-brainer.
yeah, that makes sense.
Cool. Any other last thoughts? This was very interesting. Thank you very, very much, Antonio. It's definitely squarely in the I don't know, eye of the storm, or the interest of the various parties here. On that subject, we've got a couple of topics coming up. Kevin, I don't know whether we've asked you. You've done some new workload description stuff. I think we're going to ask you to come and talk about it, the decoupled pod group and workload API proposal. I don't know if we've reached out to you, but we were going to see if you wanted to come and talk about it. Is that right, you, Kevin? Oh, maybe we lost Kevin. Yeah, we lost him. All right, I think we have Kevin queued up to talk about this thing here. We will also get Tim back at some point. Marlo, I don't know whether you have gotten a read from Tim on when he might be free to come back.
He'll come back. He just has to have a free schedule. I know we have KubeCon coming up in March.
Mm-hmm.
So yeah. I'm assuming end of March is dead for us.
But at some point we'll get Tim back to talk
we'll
about
get him back.
How Slurm handles topology awareness. That was a very interesting talk. Lots of people were interested, and I think we only started to touch on the questions that people wanted to ask there. And then John Bellamaric about DRA stuff, more DRA stuff. I think that's another topic that we were going to have. And then Victor, I think there's some sort of, I will share over at the OCP AI hardware software co-design working group that Victor is a part of about what we're doing, and vice versa, try to get somebody in from that group to talk about what they're doing. Is that right, Victor?
Yes. Yep. Yeah, there was actually a quite interesting talk last Friday. A professor from Berkeley talking about, really thinking of a full stack end-to-end co-design.
Mm-hmm. Yeah, so those are some of the things that we've got coming up. All interesting topics, all kind of related to the topic that we're talking about today in various ways, shapes and forms. So if you found this interesting, there'll be more related topics over the next coming months. Lovely. Well, thank you once again, Antonio. That was very, very interesting. Hope everyone got something out of the discussion, and we'll be back in a couple of weeks with another topic. And look at Marlo's, the white paper thing that Marlo has been driving. Check it out. Add things if you see things that need adding. And we'll talk to you in a couple of weeks. Thanks, everyone. Appreciate it. Thank you again, Antonio.
Thank you for having me.
Thanks for coming. This is really great.
Yeah, it's always a pleasure to talk with you, Marlo.
It's always a pleasure to see you. Good luck. Bye. Are you going to KubeCon?
Bye. Absolutely. I'll be there.
Right. I'll see you there. All right. Bye.
Bye.
Cool. Thanks. Bye.
Bye-bye.
Bye. Nice to meet you.